Okay, a question arose regarding how to do this experiment without Logger Pro, for example. And my answer to this question is the following. Suppose we're going to do the charging experiment only. We're going to work with the charging data only. And what we want to know is, can we do this experiment without doing a curve fit? In other words, can we bypass using Logger Pro, maybe bypass exporting the data at all? Well, yes, I think we can do it. Here's the thing. If when we charge the capacitor, it will reach 62% of its full charge, meaning 3 volts in the case of the IO lab and the 100 microfarad capacitor. It'll reach a voltage of 62% of its full capacity in one time constant, 86% of the charge capacity in two time constants, etc. So let's see if this bears out. So I'm going to go ahead and take some data, and I'm just going to record through the charging, and I'm going to stop. So I'm going to click record, and my configuration is already set. Turn on my power, and I'm going to charge it to 3 volts, and then I'm going to stop. So here I am. Here's my data, and I'm going to just turn this off so I don't burn things out. Here's my charging data right here. So let's get rid of A7 because we saw that it went up to 3 volts as it's supposed to. So now we're focusing on analog 8. So 62% of 3 volts is 2.046 volts, and that should be in one time constant. My configuration is for a 100 microfarad capacitor along with a 10K resistor, so you should get a time constant of about a second. The nice thing about the IOLab software is it comes complete with analysis tools. So now I'm click on this button here, which is the analysis tools, and now I can scroll over my curve and look what the software does. And I'm actually going to go for 5 seconds, so I'm going to look for a delta t, and I'll just drag over, and you can see the delta t underneath the red mu. I'm going to drag over to 1 second. There we go. There's 1.01 second. That's pretty close enough. And my expected value was 2.04. The value that I have is 2.13. If I were to calculate a percent difference, let's go ahead and do that. I'll just divide it by 0.04, which is my expected value. 4.4% difference. That's not bad. That's pretty good for an experiment that is basically done on a breadboard. So this is a way that we can actually do the experiment without having to export. We see the curve. What we did was we assumed that the theory was true, and therefore took a look at what we expected versus what we got. Now, with a little more precision, such as with a mouse or something, I could probably get it closer to 1.00 seconds, and I would probably get much closer to the 2.04. But as I happened to do, I did pretty nicely. The measured value you can see underneath analog 8 is 2.08. I was expecting 2.04, so I'm in pretty good shape.